In this week's GibbsCAM video, we're going to show you how to use the profiler properly. We have a part here. It's a SOLIDWORKS part, and of course if you bring it in on SOLIDWORKS, if you have any kind of holes, you will get these little green check marks and lines going through all the holes in the part. You can keep them there, won't hurt anything, but if you want to make them disappear temporarily, you can go to the View menu and just turn off Show Hole Features. That makes them disappear. So everybody that has GibbsCAM Go Solids or Go Pro Solids will have the profiler in their menus. If you just have GibbsCAM milling with no solids, you won't have this, but most everybody now has Go Solids or Go Pro Solids. So you will have this profiler down here. Now there's a drop-down menu on the profiler. There's either slice, slice spun body, slice silhouette, slice cylinder. So on the slice plane, if we turn that on, you can see you can grab this and pull it through your part. I have other videos on how to use this as well. You can also right click and then say extract the profiler or go to a profiler depth. And you can always use the Alt key, click on a surface, click apply, and it'll force that profiler down to that surface, and you can pull the geometry off that surface. And of course you can also drag it. You can also profiler select all the profiles and extract it if you'd like, or you can also just extract the profile off of one edge if you'd like. So you have a number of choices there on what you'd like to do. But let's say we want to cut the periphery of this part. So by dragging it through the part, you can see I can get this. Of course I don't want that. I want to cut the outside of the part. If I turn on my stock, you can see I have about 1/8 of an inch of material on the whole outside of the part, so I want to machine the outside of the part. So if I pull the profiler down about here, it looks good for most of it, but then it has this and this. So if I pull it down farther, then really no solution for that. So that's where the profiler comes into play on what they call slice silhouette. So if you do slice silhouette, it's just what it says. It's like a silhouette. So if you drag this, say, to the very bottom of your part, it's going to look at the whole outside of the part like a silhouette, and there's the geometry you need to cut it. Now you can extract the geometry if you want by clicking on it and extract the profile, but you don't necessarily have to. So let's say I want to machine the outside of this part now. So if I bring up my process, I can click on this profile right here, and notice it does not give you the 3 circles that Gibbs normally gives you. It just gives you the climb mill or conventional mill, either way you want to go, and the start and end points are there, and you can also move them around just like you do normally. But Gibbs already knows this is an outside profile, so you're not going to get the 3 circles on there. So if we just click on do it, we'll have the toolpath around the outside of that part. Now if I go to the rendering and just render that part, you'll just see that render so far. Let's turn on the profiler. We'll rewind it, play, and so you can see we are cutting the outside periphery of that part so far. So the next thing I want to do is machine the rest of this part, and we're going to use a couple of tools, just a 1/2 inch end mill to rough it out, and we're just going to use the same end mill to finish it. Now you can use the profiler if you'd like. Let's just drag it up there if we want to use that. We could highlight each one of these, but it's easier on this. Let's just turn the profiler off altogether, and let's turn face selection off and just select the whole profile there, or the whole solid body. Now we're going to do 2 different operations here. We're going to rough this all out and then take a finish pass on here. So let's bring up the processes here. I'm going to use volume mill, and this is my part's 2 inch thick, so I'm going to say you can go down to 2 inches if you need to. I'm going to side mill cut. I'm going to leave a little stock on the X, and Z will take to finish. and minimum toolpath, etc. But I'm going to say hit flats by adding passes. So since each one of these surfaces here, let me turn on face selection, that's a different depth than this, and a different depth from here, and this is a different depth as well. So by clicking on add flats, hit flats by adding passes, it'll change the depth. But I want to go down about an inch at a time, so it will adjust that how it needs to make sure we hit the flats on everything there. So we're just going to click on the whole solid, and we're just going to click on do it. And I'm just going to take a finish pass as well on here. Let me bring that up, and I'm going to again say you can go -2 inches, but add hit flats by adding passes. So we're going to take a finish pass on there, so we'll just say do it. And it's running the process here. And now we have our roughing and our finish process on there. So if we go back to our operations, we can now see it got the outside and of course all the steps. And you'll notice it'll adjust the steps as it needs to. Take another heavy cut on the outside there, and of course take our finish passes, well, once it finishes this cavity here. Then of course the finish pass on all there. Now of course let's we have a, choose a blank tile here. We have a chamfer around the part there, so I'm just going to click on face selection here, and I'm just going to extract the geometry off that. And we're going to clear this out. I'm just going to use a contour with our tool we're using to chamfer with. I'm going to go down to -0.3, and we'll do a little bit of a arc in and arc off on there. And this time we're just using geometry. We could use a profiler as well, but I'm just going to use geometry on here. And we'll click on do it there. We'll do this after the and now we have our chamfer. So the next thing we want to do is machine the holes now. Now I'm going to show you how to use the hole manager here. So let's turn off our cam for just a minute there, and I'm going to actually turn off the geometry to hide some of that. So next we want to do the holes in this part. So we have a 3/8 holes, 1/4 inch holes, and 7/16 holes. So let's bring up the features and hole manager. Now if this is blank, all you need to do is click on the solid, make sure the whole solid is selected, not on face selection, and click on Run AFR. And that's going to find every hole in that part with the chamfers and everything else in there. As you can see, it found all the holes in there. So what we're going to do is click on Auto Group, and it's going to create 3 different groups in this particular one. And the group number 3, you can see it highlights all the 1/4 inch holes. Group 2 highlights all the 3/8 holes, and the last group all the 7/16 holes. So we're going to use Auto Wizard here, or Hole Wizard. I don't want to use Auto Wizard. Don't use that too often. I like to use Hole Wizard, where it steps me through everything so I can see what it's actually looking at. So I'm going to click on Hole Wizard, and this is going to be the 3/8 holes. So I want to do a spot drill and drill, not do chamfering. Spot will chamfer the hole already, so click on Next. Everything there is good. Next. Build the processes. Now one thing you need to do is open this process, hole features, and adjust for the tooltip there. So we'll click on that. Build the operations and finish. So now we have the operations over there for the 1/4 inch holes. Okay. Now we're going to select a empty tile over here, clear this out, and let's go to group number 2, which you can see it highlights all the 3/8 holes. So again, let's do the hole wizard, sorry. Next and next. Build the operations. Let's adjust for the tooltip there. Build operations and finish. Now we're done with the 3/8 holes. Now the last one is group number 1. So then let's go through hole wizard. Next, and clear this. Rebuild processes. Open this up and adjust for the tooltip. And rebuild operations, and we should be good to go. That did the 7/16 holes. So now let's go to render and take a look at everything. So we'll start right off from scratch. And we'll slow it down when it gets to the holes here. Okay, slow it down, and you can see here's the 3/8. And of course the 7/16. Now, to save a little time, since we're using the spot drill on all these and then doing a tool change, it'd probably be easier to put all the spot drills in one spot. So in order to do that, just go anywhere on the operation list, right click and say sort operations, and that's going to sort them all in the correct order, so all the spot drills are in the same order before it does a tool change. So it'll eliminate a little bit of tool change there. So let's run the rendering and you can see what that does. So we'll speed this up and we'll stop when it gets to the holes. So let's just slow it down a little bit. Now you can see we're going to spot all the holes first, and then of course drill all the holes 3/8, 7/16, or sorry, 3/4, 3/8, and then 7/16 there. So that's a little bit on how to use the profiler on the mill. So let's bring up a lathe and we'll show you some things on lathe that makes things much easier to use. So the next part with the profiler is how to use it on a turn part. So here you can see I have a turn part, kind of like an MTM part. I'm on the ZX plane, so that's the turning plane, as you can see. Now we do have the get section in here like we've always had. So click on the solid, go to get section, and the default there. But the problem with the get section is you can see it sliced it right through the body there. Of course, if we were to turn this and turn it at this diameter, it would of course cut these corners off here, and of course it sliced it down through the holes. So turning on this, so we'd have to do quite a bit of cleanup here to get things to cut right. So normally I don't use get section anymore since the profiler came out years ago. So on the profiler, let's first we want to, well, let's just do the OD first like we're turning. So if we go to the drop down menu and click on this button right here that says slice spun body, Gibbs will look at this part as if that part was turning in a lathe. So if I click on that, you can see the profile here. And if we turn this, it would match everything here perfectly, and we'd have a good looking part there. Now you can always click this and right click and extract the profile if you like. In case you want to do some measurements or something, there's the profile for turning. As you can see, it's a little higher up here because that's what it would look like on this surface here. Same with here. Okay, let's delete that. Now let's say we want to do milling on here, say from the face, come in with the end mill and cut this, the flats here and the flats here. So if we go to, first of all, you want to make sure you're on the correct plane. So let's go to the XY plane. You can see that's the front there, the XY plane. And if we go to the standard slice plane, we can drag this down through our part anywhere on here. We can also, of course, right click and do a profile depth. Either way we'd like to do it. But let's, for this particular part, we can just drag it anywhere through here. So we could click on that, extract the profile, turn the profiler off. That looks good. So there's geometry to cut the flats. Now let's say we want to cut flats on this again, coming from the face with, say, an end mill. So we could take the profiler, drag it through here. That doesn't look so good because it's slicing it through the holes there. Let's say we bring it back a little bit farther. Can't quite get even with the outside here and here, so we're going to have an undercut there. So if we tried to mill that, we'd be cutting into this surface here. So that's another reason to use the slice silhouette. So if I click on that and drag the profiler just maybe a little bit past it, you can see it looks at this surface like it was a profile, and you can see that matches the part perfectly. So then if we want to, we can extract the geometry off that, turn the profiler off. If we want, we can actually put this by going to force the depth. I'll click on maybe this surface here. If we want to bring that over to this surface here, that's easy to do. Again, if we want to do this with the end piece, we could do the same thing by alt-clicking on the end there. Of course, that would be Z0. So now we have it placed where we would like it. It doesn't really matter. You can have it here or here, but it's more customer preference what you would like. So there we have the hex on the end and also down here. So that's an easy way to use the profiler. So much easier than doing the slice on that. Makes it easy to machine. Now the next lathe part we're going to do is show you how to unwrap geometry or cavities on a turned part. So that'll be next. So here is our turned part that we want to do some polar and cylindrical milling on this cavity right here. So in the past you could click on the edge selection, select the edges, then go to modify and unwrap. But if you want to use the profiler, which makes things much easier now, we don't need to do that. Here's our part. Make sure you're on the XY plane though, whereas before you'd be on the YZ plane. But now we'll be on the XY plane, and we'll click the profiler and go to the very bottom where it says slice cylinder. Now the slice cylinder, the only thing you need to make sure is you have the profile at the depth that you're going to turn to. So in this case it's 2 inches. You can of course right click and say profiler depth, and in this case it's 2 inches. You can either slice this and measure that, or if you have a print you can see what this diameter is. So we already have the let's do this again. We could profiler depth, 2 inch, apply, and it's down at 2 inches there. So all we need to do now is our cam section. Let's open up our volume mill. And of course on the rotate tab we want to make sure we're on the YZ plane, because that's the tool is going to come radially on the part. And we want to make sure it's on polar and cylindrical milling. And of course this is where your depth will be 2 inches. This is from center line, so basically radial from the depth up to that surface is 2 inches, and up to the outer surfaces is 2.5 inch, and this is radial value. And of course you machine that. When we finish off the same thing here, make sure you're on the rotate tab, YZ plane, polar and cylindrical, and then if we run the simulation there, we'll rewind and play. And this of course is volume mill doing polar and cylindrical. And then of course finish pass on here. Of course we want to clean up the bottom surface as well, so that's why we selected roughing to take a finish pass on here. And then you have your part finished on there for polar and cylindrical. So that's how to use the spun slice cylinder for for doing rotary milling on the outside of a part. So you can see toolpath there, looks very nice. Click on the volume mill, same thing there. So that's kind of how to use the profiler successfully on not only turn parts but milling parts as well. And thank you very much for watching.